today's class about fifth generation core network basic knowledge. Our class is about basic theory. So the class will divide into two parts. The first is the business requirements and visions. The second is the reconstructed network architecture. So let's have a look at development tendency of mobile communication. First is one generation. The first generation in 1980. In 1980, we can use phone to provide voice service, basic on the analog signals. And then is the second generation. We can use phone. We can use phone for the voice call, and higher call quality. It will provide voice communication service based on the digital signals. The third generation, in 2000 we can surf the internet. The third generation can provide voice communication and data communication service based on the digital signal and IP architecture, and support access to the internet through mobile terminals. And then is now the fourth generation. We have faster internet speeds in 2010. Based on the flat IP architecture, it provides data communication service and supports mass application based on mobile terminal access to the internet. Then here comes the 5G generation. And in fifth generation, we have lower latency and we have larger bandwidth, and our connections is more massive. There are three typical scenarios in 5G, such as the MMTC, URLLC, and the EMBB. So the development of mobile communication basically is a decade generation. The move from the early 1G to the current 4G is larger driven by the need of improved voice quality and large data bandwidth. The upcoming fifth generation seems to be one generation more than fourth generation, but in fact 5G's feelings are much larger than 4G. It can be said that 4G is still in the final stage of quantitative change, while 5G has already undergone qualitative change. So this is the development of tendencies of mobile communications. And then let's have a look at the driving force of 5G themes. The first is the EMBB, enhanced mobile broadband. Let's have a look. In 5G, the bandwidth can be more than 1600. And only 5G network can meet needs of AR, VR, MR, and Ultra HD video and other super large bandwidth. So this is the first force of 5G theme, and let's have a look at the second driving force of 5G theme. In the 6 major vertical industries corresponding to 5G, the time delay requires are basically less than 200 milliseconds. And in the 4G, it's about 50 milliseconds delay. So it becomes the bottleneck of industry development, and the 5G's low delay can perfectly solve the problem of delay demand. And let's look at the picture. In 4G, it cannot meet the requirement of 10 milliseconds. So the vertical industry has a growing demand for ultra low latency, and only 5G can drive the industry's technological revolution. We call the second force of 5G theme the URLLC, ultra reliable and low latency communication. Okay, have a look at the third force of driving 5G theme. It's the IoT. It's the Internet of Things. In 4G, the network is about connecting people, but in 5G we have the super connection. It's about the Internet of Things. We call it MMTC, Massive Machine Type Communication. In the 4G connection density is about 100,000, but in 5G, we improved density to 1 million. It's a big improvement. So IoT promotes the surge of terminal access. 5G is imperative. So there are three types of 5G scenarios in the network. The first is eMBB, the second is MMTC, and the last is URLC. eMBB means enhanced mobile broadband, and the second is the massive machine type communication. The last is ultra reliable and low latency communication. In the future, the product technology graduate focus on the 4 application scenarios. The promotion group conclude that the application of 5G in the future mainly focus on the 4 scenarios: high-speed railway, subway, and other continuous wide area coverage scenarios. High-capacity SIMs in residential areas, office areas, open-air gatherings, and other hot spots. Smart city environmental of virgins, industrial control, virtual reality, and wearable device, and other reliable things with low time delay and high reliability. Therefore, 5G technologies and product development should also focus on these 4 scenarios to cutting-edge technology and product development. Second, 5G technology will stimulate new customers' demand. An important feature of 5G is that it can realize the connection between people and things, and the things form the interconnection of everything, and integrate in work, study, and environment, social interaction, industrial production, and other aspects. Gradually, rich consumption patterns will promote major changes in user experience, demand, and future stimulates new industries, new forms of business, and new models. Therefore, it's necessary to make full use of technology and product reserves. Timely check the dynamic changes of technology and the products, and arrange disruptive technologies and products as early as possible. Third, industry integration and transformation accelerated. Based on the support of 5G technologies, the cross-industry integration development is future strengthened, and the new type of information and industry will be deeply integrated, triggering profound change in the industry field. 5G technologies such as mobile Internet of Things scenarios will penetrate into industries such as consumption, production, sales, and service, and the future promote the development of research and development, design, marketing, and service to the direction of digitization, intelligence, and coordination, so as to realize intelligent management of the whole life cycle and the whole value chain in the industry field. So this is the typical 5G application scenarios. And let's look at the 5G KPI surpass 4G in all aspects. For example, the traffic density is a big improvement, and the connection density, time delay, mobility, energy efficiency, and the user experience, spectrum, peak rate, all of the paths has been surpassed 4G. So the three application scenarios of network requirements are increasingly high. 5G is imperative. And the four key performance indicators of 5G network is the time delay, the peak throughput, and the connections. The last is the high speed mobility. The time delay can be as low as 1 millisecond, and the peak throughput can be as high as 10 gigabytes for one user. And the connection, we can connect more than 1,000 per square kilometers, and the speed is more than 500 kilometers per hour. So this is the four key performance in the indicators of 5G network. For the ICT, Fusion provides new development for 5G core network. For the platform, if the emergence of WiMAX and the popularity of iPhone had for other industry of IT industry into the city industry, then under the background of development of 5G communication network, the city industry has to innovate to change the status. And after the introduction of NFV SDN technology, the communication network will realize network function virtualization, service, flexible activation of network scheduling, and the flexible allocation of network resources, cloud environment development deployment based on the common x86 server, supports dynamic allocation of resource, and the higher available software architecture enables faster and more agile deployment and troubleshooting of applications and infrastructure, significantly reducing enterprise deployment costs in cloud computing. The application of big data and AI technologies make network maintenance more intelligent and efficient, and the positioning of network problems more accurate and fast. Looking ahead to 2025, 5G will bring a whole new world. Everything will be connected everywhere, and the intelligence will follow you at any time. For the virtualize your world is anywhere, in anywhere. Virtualize your world in anywhere. The cloud architecture will make the network more flexible, and the sharing economy restructure business. Okay, that's the business requirements and the vision of 5G technology. So let's have a look at the reconstructed network architecture. Okay, we all know 5G is coming, but how to adapt to multiple business scenarios, and how to reduce operational complexity, and how to get business online quickly. There are all kinds of problems, and how to solve the problems. Then we have the network, we have the cloud architecture, which the business cost innovation. Let's have a look at architecture, and the the first layer is about the infrastructure resource layer. The second layer is about the business enablement layer. The last layer is the business application layer. The architecture is based on the NFV and cloud computing. NFV means the network function virtualization. And for the bottom layer, the infrastructure as a service, the IaaS is a cloud computing service, and the PaaS is the platform as a service. Is also the one conception in the cloud computing. And here is the network as a service. We call it SaaS, service as a service. Okay. So the bottom layer is software-defined infrastructure. The second layer is software-defined network function, and the top layer is about the software-defined network slice. What is a cloud architecture? This section describes the conception of cloud architecture and describes the future of the cloud architecture. Software-defined service interface is the entire network provides open API interface at each layer, which facilitates the access of different types of terminals and the use of network resource, and facilitates the secondary development and expansion of third-part service based on network interface to implement new network-based service. And for the software-defined infrastructure, through the virtual layer implemented by the software, hardware devices are virtualized into multiple virtual machines. Users, based on the network of the layer, only need to focus on the virtual machines they use, and don't need to focus on the specific hardware device. Technology, we use the technology is the virtualization, NFV, SDN. Virtualization is the technology of how to virtualize the hardware device into the virtualized resource. And the NFV, we call it network function virtualization. SDN is the software-defined network. So for the software-defined network functions, the virtualization technology provides a platform for developing and running service software, making network deployment and life cycle management more convenient, and making new service available more quickly. And for the technology, we use the container or SPA. The last layer is the software-defined network slicing. We provide network slice based on the specific requirement. Different services can operate on slice with different features and don't interfere with each other. And we use the network slicing as the key technology. So this is a 5G cloud architecture. This is about the 5G cloud architecture. And for the core network element configuration achieves the network flexible. We can see this is a 4G core network system. This is a 5G core network system. Later we will have a class about the 5G core network architecture. We will describe each element's function in detail later. So for the evolution of 5G to 4G, from 4G to 5G, we can see the MME and the S gateway or P gateway. We evaluate to the AMF and the SMF. For the MME and HSS, we evaluate them to the AUSF or UDM. For the S gateway user plan and P gateway user plan, we evaluated to the UPF. For every element's function, and we can have look. Also, we will have a detailed description about all the network function in 5G in the later class. And that's all about our 5G core network basic series. And thank you for listening.